All right, Tianren, you want to kick us off, or you want me to do it?
Yeah, okay. Okay, let's start. Hello everyone, welcome to the OPSAWG and the OPSA area meeting. This is an online virtual meeting for the IETF108. As usual, next slide. As usual, we start from the note well. Please make sure you understand the note well and those important legal issues. Basically, all your contributions, including your write-up, the presentation, the audio video need to follow the IETF rules. And next. Yeah. Firstly, welcome to the OPSAWG. It's chaired by Tianren and Joe. And the blue sheet is automatically recorded. And do we need a Java, Joe?
I'll watch the chat. Or watch the chat when you're not talking. When I'm talking.
Okay, thank you. And as we have stated, since there is a recording, we can get the minutes from the recording, and you can also, everyone can help for the minutes with the pencil icon. And we have a full agenda, so if you speak over time, we will have to cut the line or stop speaking. And next. Here's the working group status. 2 working group drafts, the text protocol and the SDI, are in the RFC edit queue. We do not have much thing to do. And 2 working group drafts, the Tackers Yarn model and the model automation framework, finished the last call, and we just submitted to the IESG. And the network telemetry framework draft is getting stable. The authors think it's ready for a working group last call. And L3NM and L2NM get a lot of discussions in the mailing list, and there is a major change. The common VPN model is extracted. The author will present the update and the common VPN model today. Any more, Joe?
No, just that the new Meet Echo format here. If you want, on the minutes, if you launch the CodeEMD in a different tab, that way you can have both up at the same time. If you want to add some thoughts, and we have a 5-minute gap at the end, and then Meet Echo will hard cut us off, I'm told. So just again, as Tianren said, be cognizant of your time. That's all I have to add.
Yeah. Okay. And any other more? And here's the agenda. We have the OPSAWG have 5 topics. Is there any agenda question? If no, I think we can start the presentation and the discussion.
All right, Oscar.
First one, Oscar.
All yours, Oscar. I can't hear you if you're talking.
I cannot hear anything. No, we cannot hear you.
Now, can you hear me now?
Yes, absolutely.
Yeah,
sound good now.
Perfect. I have the double mute. Okay, so this is the most common problem these days. Okay, so we'll start with an update on the several VPN related modules, which is the 2 working group documents. This is the L2NM and L3NM, and the new individual document that came out of them. Okay, so please, next slide. Okay, so which were the goals of preparing the next version of the L3NM? We had three main goals. One of them is address the comments that we received in the mailing list from the people that were implementing the draft, which we received a few of the comments. The second goal is to address the Young Doctors review, which also was sent a bunch of comments. And the third one is that, as you know, we are maintaining in GitHub a list of issues with additions to the draft or new things that can be covered, bugs, etc. So we want also to reduce this list of open issues, so we progress through our through the last call. So please, next slide. So with to be able to address the first two goals, we have been working in a proposal of a common Young model for applicable that is applicable to both layer 2 and layer 3 VPN. So please, next slide. So these are the set of modules that are in play here. So we have two already RFCs, which are customer service models, and we have the two IDs that are part of OPSA, which are the layer 2 and layer 3 VPN network models, which is the service as seen in the network and can be implemented by a network controller. And also we have a new addition, a recently addition, that is the VPN service performance monitoring, okay, which complements the draft with this performance information. So we have many nodes that are common between the different models. And the issue is, okay, how can we reuse these components in a clean way? So please, next slide. Okay, so the first attempt that we did in the first version of the draft is, okay, we have the L3NM, which uses some of the things of L3SM, and we have L2NM that, okay, uses some of the groupings and some of the definitions that we did in L3NM, and also part that we came from L3SM and part from L2SM. But, next slide, please. This line of work was a little bit abandoned because we received feedback from people implemented that they interpreted that, for example, having L2NM using components from L3SM, it was interpreted as, okay, the L2 requires the L3. So people say, no, I am just implementing L2, I don't want to implement L3. Also, that the L2NM uses things from this L3 service model, it was interpreted also as a violation of layers. So forget this approach, go next one. So this is why we decided, okay, let's have a VPN common module in which the two common modules that we are, the two modules that we are defining now, the L2NM and L3NM, uses this VPN common module. So next slide, please. And potentially, the idea is that as per suggestions in the mailing list, that the two already existing service module could use in a future, if they have a BIS version, they could also benefit from this VPN common module. Okay, so please, next slide. So the approach is to extract first that the nodes that are common for both the 3NM and the 3SM, and then we filter out also against the layer 2. So we are starting just with everything that is common between all the modules, and we did a check that all these common groupings are available and are referenced in the L3NM. So we think that from the design perspective, that goal is met. So the scope, as mentioned, is clear to everything that is available in all the documents. So there are some things that are common between L3NM and L3SM that are not in L2, okay, but these are not in the common module now. Okay, just to clarify the scope. So next slide, please. So what is the next step for this one? So what we have been doing in this common module is just take out the common groupings from the main modules. The main modules are, let's say, not changed. Okay, so the content is from there. So we do think that this is a seems a good approach. So we request the working group to endorse this approach. Okay, so we want to ask you if there is any objection here, and our question is, okay, if you are happy with this way of working of this VPN common module, if we publish this as a standalone document, okay, so this draft that we have published as individual working as individual document, we adopt it and we go with it and publish it as a standalone document, or we include it in the L3, for example, in the L3NM. Okay, so here we would like to hear your thoughts. I don't know whether you want to wait till the end of the presentation or now.
No, let's. There's a few things here to explore. First of all, to the working group, before we get into any hums, are there any objections to this approach of breaking out the common types groupings into this module? If you have any objections, please go to the mic line now. Okay, not seeing anyone get into the line. Though Jeff Haas says in the chat, refactoring the common stuff at this point is reasonable since the model has reached some maturity, and Jeff has asked for the audio. So you have the mic, please, affiliation, name, and go for it.
Jeff Haas with Juniper. This may be faster in typing. The refactoring at this point is reasonable because the models have actually gotten enough content that makes sense to do so. The main thing I suggest is look for things that are appropriate for IANA to maintain so that you can separate those into a separate module and allow those to be extended without necessarily limiting other things that may want to use it in the future.
Thank you. So that brings us to a hummable question here. So there doesn't sound like there's any other objections. In fact, one support with reasoning. So the question you raise is, should this effort be published as standalone? Jeff made an argument to kind of make this as perhaps agnostic as possible, or should it be included in the L3NM draft? So if everyone could go over to the kind of survey looking thing next to the chat thing on the left of the right or left part of the pane, we're going to start a hum. Hum if you feel this should be a standalone document, this VPN common module, if this should be in a standalone document. And the hum is now active. You can either not hum softly, or hum loudly. Okay, the hum is closed. Forte is perhaps the loudest we could have gotten in here. Chairs are not allowed to hum as participants, and I think some of the Meet Echo people in here can't hum. Nonetheless, one more, if you feel that this should be, so hum now if you feel this should be included, this common module should be included as part of the L3NM draft. And pianissimo, so very soft, though maybe some, but it sounds like from a consensus point of view on this call, Oscar, the thoughts are that it should exist and be there wasn't any objection, and should exist in a standalone draft. We'll of course ratify or get final list consensus, but it sounds like you have some direction there.
Okay. so then we will wait for your indications for the adoption. Right now it's an individual document.
Right.
Okay, so as this has, or the other data will depend on this one. Okay, so
yeah, we'll as chairs will conduct the call for adoption on list after this, and that will be your formal indication once that call for adoption ends as to the way forward, way to proceed.
Okay, thank you very much. Okay, so how much time do we have left for the rest of the presentation? Just to...
You have a good amount of time. We were a little bit short on our section, so you have 15, 10, you have about another 7 minutes or so.
Okay, perfect. Okay, so then the second objective, as we mentioned, was to restructure the L3NM module. So please go to next slide. So we are next slide, please. Okay, here. Okay, so we did the after the young doctors review that noticed that there were a lot of groupings that were unused. So here we have some statistics of how now the new document looks like. So, for example, the groupings were from 35 groupings that we have in the first version of L3NM. In the version that we were preparing using the common module, it has just 2 groupings specific in that module. So in the common one, we are having like 8. So you see that we reduced significantly the number of them. Also, we made the changes on the description classes, etc. Okay, so I received some from the chat that we are not sharing. Yes, the screen is shared, I think. Okay, please, next slide. Okay, and then the third part is solve the open issues. So just next slide. So the first thing is the issues that are closed. So we closed since the last IETF meeting 16 issues. So here I'm not gonna go in detail of them, but I have sent a full report to the mailing list so people can check all those issues that were closed. So if anyone finds that any of them needs to be revisited, reopened, please go and check there. Okay, so for example, just to highlight one of them, we have the RTRD auto-assignment issue. So we closed one of the issues related to that, but later this one, as we will see, it was reopened by the solution did not convince the implementation. So we have reopened with just minor fixes. We have all the young doctors review done. We have some issues with the policies. We mentioned whether it was possible to add a leaf ref or just a string or hook. And for example, people decided in the discussions that it was just better to leave a string with a hook and a pointer and avoid the complexity of having a full leaf ref and to maintain that. And also we incorporated, I think this is important, a new kind of policy, not only routing policies, but also we incorporated the forwarding policy. So that is the behavior on the packets that enter the BRF, so to differentiate those. So for example, the forwarding policy, you can do it with an ACL. And we just here add a name to the policy, okay? So we don't enter in the draft how it is done. So there are other works in the IETF to tackle that. Okay, so please, next one. And we have right now at this moment 16 open issues. Okay, so you can check them in GitHub. For example, there is some proposal of simplifying the IP connection. There was a proposal of adding the service type identification. There are some descriptions and some references to add. There is a very interesting discussion that also was made in the in the open to the list for the BGP session parameter support. We know that the BGP session is one of the key topics in the CPE communication. So people wanted to expose northbound some of these parameters. So the discussion is on how much we open from BGP. This is not a device model, but we are leveraging some northbound. So here there are already 9 pull requests to close some of these issues. They are pending for reviews, for some text. Okay, so you can chime in and please you can review, discuss. Okay, so next slide, please. So just to highlight what is one of the issues that has been going recurrently. So we had a solution that did not fully was not fully adequate for all the implementers. So after the feedback received and several conversations, we finally decided to go for the explicit solution, very easy to implement. That is a choice with the 4 different cases. So the RT and RD are assigned directly. They are assigned automatically by the controller. They are assigned based on a pool available on the controller, or we don't want any RT or RD. Okay. So this is the topic that was raised more discussions also in the list, so it was to highlight it here. So please, next slide, and with this I finish. So the next step is release the 04 version, which addresses all the comments from the implementers and the young doctor review, and includes the common module. And then we'll work in resolving all the remaining issues and issue an 05 version around, I think this can be around October, and by that time we think it could be then candidate for working group last call. Okay, so when we close all the pending issues, that just you see that there are a few. So reviews and comments are welcome here. So with this I finish my presentation.
Thank you, Oscar. Questions? We have about a minute for questions. Benoit, I see you're asking if you would like, I can read it, or if you want to get in the mic line, you can ask yourself. Well, he asked to send audio. So here is Benoit. All you, Benoit.
I think it was answered in the chat via Mo. So basically, I was thinking for the rest of the audience, I was thinking that maybe the young doctor's review could be revisited because we wanted to have something in common with your 3rd draft. And Mo replied that actually, even that one, I was too optimistic to believe that the groupings would be used in 2 or 4 drafts. So I think this was answered by Mo.
And then while your full name and affiliation, just for those who may not know.
Oh, yes, sorry. I'm Benoit Claes. I'm with Cisco.
Thanks. Any other comments? Okay, thank you very much, Oscar.
Thanks to you guys. Thanks for all the participation and comments.
Next, clicking the shared screen. Next up, we have Thomas.
Yeah, hello, can you hear me?
We can.
Perfect. So Thomas Graf from Swisscom. I'm presenting here a new draft for export of MPLS segment routing label type information in IPFix. It's basically about adding segment routing dimension into the IPFix IANA registry. Next slide, please. So looking at the IPFix packet capture from an MPLS segment routing network, we see pretty much that basically MPLS segment routing is using the MPLS data plane. We see the MPLS top labels, transport labels, the top label, IP address, prefix number, and so on. But what changes from MPLS to MPLS segment routing is basically the label protocol, the protocol which provided the label from the control plane. And here, in this real-life capture, we see LDP, even though it's no more LDP, it's now segment routing. And the reason for that go to the next slide. We find easily at IANA at the IPFix registry, if we go into the IPFix MPLS label type, we immediately see that the segment routing is not present. And what's missing is basically the code points for ISIS, OSPF v2 and v3 segment routing. Next slide, please. Going one step further, segment routing is about SID types. So these SID types have actually a meaning. It can be an instruction, it can be a service, it can be a topologies. RFC 8402 describes basically what SIDs are possible at segment routing. And looking at the IPFix IANA registry, we don't see anything relating SID types. So that's missing as well. Next slide. So just to give you an example how the SID type could actually help to give us visibility in how segment routing is actually steering, forwarding the traffic within the network, is if we would have the segment routing SID type dimension available in case of TILFA, one of the applications of segment routing, then we could do easily with the collected metrics a query saying, show me all the MPLS segment routing control traffic where adjacency SIDs are used, group them by label stack, and show me through which interfaces and nodes this has been forwarded. So that allows you then very easily to see when basically TILFA jumped into action. So basically what it means, it's we need to update the MPLS top label type registry, and we could add, introduce an SSI type registry at IPFix IANA. So next slide, please. I already have collected feedback from the Spring and OPSAWG working group. I'm also, since I presented yesterday at Spring, I received feedback. I should also collect feedback from LSR and MPLS, which I just did today. And I submitted a request to IANA, received already in an IPFix entity doctor review, and I would like to call adoption on OPSAWG working group.
Thanks, Thomas. So it's hard to get, with a 35-second timeout, both a call for who's read this and who supports the work. So first of all, let me ask, are there any comments on this work for those who have read it? Okay, let's do a quick hum. So hum now if you support the adoption of this work in OPSAWG, or OPSWAG as the case may be, according to the slide. So hum if you support this work, adopting this work in our working group, OPSAWG. So middle of the road, piano is the result of the hum. So maybe some support. Forte was the last strong or indication of strongest support. So piano. So not the quietest. We'll take this to the list and see. We'll do a call for adoption there, Thomas, and see if as a participant, it seems. Without the chair hat, it seems like useful work. You've done the due diligence to talk to those in the segment routing working group to see and incorporated their feedback. So we'll do a call there and see if there is overall interest from the working group in adopting this. Oh, and it looks like there is something in the chat. Okay, I was, that may have been a previous message. Or maybe it is about this. Expert review is enough, but a draft doesn't hurt, from Benoit. So thank you, Thomas. Next
thank you very much.
up, we have Elliot Lear on MUD SBOM. And Elliot looks like you.
Good afternoon, good morning, and good evening to everyone. Thank you for giving me some time to talk about software bills of material and MUD. Next slide, please. So, what is an SBOM? Okay, we discussed this a little bit on the list. It's a software bill of material. By the way, I'm presenting this on behalf of myself and Scott Rose from NIST. This is a software bill of material is essentially a software inventory or a software manifest of the device or a package. And so you could think of it as doing like APT list or an RPM-QA to find out what's on the device. And there are a couple different formats for how a software bill of materials could be generated. Here are three. I'll tell you a couple of more. So SPDX is an emerging standard from the Linux Foundation. SWID is an existing standard from ISO, and Cyclone DX is its own thing as well. You could also imagine these things being shared in more simple form in the form of, say, God help us, XML, XLS spreadsheets and things like that. This is very emergent work. Next slide, please. So what can SBOMs be used for, and why does anybody care about any of this? Right. The first is that if you have a bunch of packages and these SBOMs contain relationships between packages, then if you're like a downstream supplier of a big software package, you can look upstream and determine if you have any license pollution. That is to say, suppose you're using GPL when you shouldn't be using GPL, as an example. Another example is cybersecurity vulnerability analysis, and this is a pretty classic one. We'll talk a little bit more about this in some detail. The example here is you're a supplier, you're delivering to the customer, and maybe the customer wants to know when OpenSSL announces a vulnerability, are you vulnerable for any particular version? And do you even have that version on your network? And there's a third, which is dependency analysis for critical systems. That is to say, are the packages that you're using appropriate for critical use? And if you evaluate them, do you find that one is a weak link, for instance? Next slide. So what does any of this have to do with the IETF? We're not the ones driving SBOMs per se. They're being driven elsewhere. The healthcare industry is driving these. They're looking to require these software bills of materials. We saw some discussion in the SUIT working group where a gentleman who works in the energy sector indicates that the North American Electrical Corporation already requires a certain software bill of materials for their devices. So we're not pushing these things. We just happen to notice that they exist. And the astute will notice, by the way, that they sort of turn responsible disclosure on its head a little bit, but for the fact that everybody's doing binary analysis of anything they could get their hands on anyway. So the big question is, how do you go find one of these things? In the proof of concept that was done at the NTIA, all they did was send them around using email, and then the next round they stuck them all on a common file server, and that's fine for a proof of concept. But in real life, that's not the way things are going to work. You have to actually know how to find these things. So you need a discovery mechanism. It so happens I have one. And that's a pretty good opportunity for manufacturer usage descriptions. And what's interesting about using manufacturer usage descriptions for this one is that we're not talking about access control or anything like that. We're talking about merely an attribute of the device, which is that this thing has a software bill of materials. And so there are several different ways in which you might locate one of these software bills of materials. One of them is the thing on the device itself. The other is it somewhere on the cloud? The reason it might be on the cloud and not on the device itself is because the device has no interface to retrieve the darn thing. The third is that you might actually have to make a phone call. The medical people are particularly careful about what information they release. I just got off the phone with a medical device manufacturer and said, we're not releasing any of these SBOMs unless, of course, we have the appropriate customer relationship and there's an agreement as to how the things are going to be used. And what format are these things in? This is another thing that needs to be discovered. Is it the SWID or Cyclone DX or SPDX or something else? Right? So these are the two sort of mechanisms that have to be answered. It turns out MUD is a perfectly fine way to answer the former question, and the latter question is conveniently answered by something else. Next slide, please. Which would be the my media type down on bullet 5. So we have this draft. It's early days. This thing extends MUD, as I mentioned, to allow you to mention the various that the thing has an SBOM. It extends the Yang model for MUD to say, and here, by the way, is how it looks. It allows for local cloud and call me options. And it specifies a mechanism for local access, like if you're going to use local access, is it going to be a COAP or HTTP or HTTPS? And if it is local, then we create a well-known registry to go retrieve the thing. And when we do that, right, you go to retrieve it, you can use the My Media types to indicate what the format is. Now, our assumption in this is that the tooling, the receiving end of this SBOM, the consumer, is going to have to be able to handle pretty much all types. We make that assumption because the chances are that a device is not likely to choose multiple formats, but even if they are, it turns out HTTP is pretty good about that, and I presume, though I do not know for sure, that co-op would have a way to allow for this. We might have to be a little stricter about co-op, and that is something that the draft needs review on. And so it relies on the underlying protocols to establish whatever security is needed. So for instance, if we're talking about HTTP or HTTPS, then presumably one would use the security mechanisms in HTTP or HTTPS in order to manage authentication and authorization. For COAP or COAP-S, the same would be true. Next slide, please. So the draft's out there. In fact, there's a POC out there. I can talk a little bit about that. It took an entire 30 lines of code to write the POC. 30 lines of Python. Ain't that cool? But the first question we have is, are there more than one of these software bills of material on a device? And if so, how do you go retrieve them? We haven't really addressed that in the draft yet. And the reason we haven't really addressed that in the draft yet is because we're sort of subservient, if you will, to the work that's being done elsewhere. But nevertheless, it's probably something that's easily resolvable by saying, well, you just go get the part of the thing that you retrieve first is a manifest of these SBOMs if necessary. And then if that's the case, then you can go and retrieve each and every one, or you retrieve one SBOM which has references to the others. And that works for everything unless all the SBOMs are disjoint, in which case, well, we need a manifest.
Elliot, there's a question in the queue. Do you want to take a question now from Michael?
Michael, let me finish this page, and then I think I'm pretty much done, and then you can ask as many questions as you want, okay? So the big issue we have is with SBOMs, they don't solve every last problem here. In particular, there are naming issues around OpenSSL or any other package where, maybe you see the name, it looks familiar, and you know that there's a vulnerability, for instance, in a particular version, but maybe the vendor backpatched it, backported the patch into one version. In which case, when the SBOM is released, what ends up happening is that your phone rings off the hook because they see that you've got OpenSSL 101B, right, or some other package like libxml that might have a bug or whatever it is, right? You backpatched it, but your customers don't know that yet. So this is not something that SBOMs deal with directly. We know we're going to need to do more work on that particular question. It may not be 100% tightly bound to this particular issue, but it's something that we know we need to address. And then I think that's I think I have one more slide, but before we do that, let's go for questions.
Okay. Michael, you have the mic.
Hi.
Name and affiliation, please.
Michael Richardson, Saddleman Software Works. So this is great work. Thank you, Elliot, and I hope we adopt this document. I thought the business of the telephone call and the other stuff was a little bit interesting. I guess I'm a little bit confused by the bit of the SBOM local and how you've enumerated a bunch of mechanisms, but then said the URL is well known. And I'm wondering why you just merged that into the URI in the first place.
Yeah, thanks for the question, Michael. Let's think about what you've got. You've got a device that's on a network. It's reporting in a MUD file that it uses, that it has an SBOM and it's accessible via HTTPS. So where do you go look for the SBOM at that point? Well, it's possible that you could just say, let's go, here is the locale, only in the MUD file, you might have many devices using the same MUD file. So what host name do you put in the domain part for the SBOM? And I didn't have an answer for that. So what I was going to say is, let's just choose the mechanism and create a well-known URI, in which point you can then retrieve, you can fill in the host name with your local information. Does that answer your question?
I understood that part. I just didn't understand why. It seems weird to enumerate CoAP, HTTPS there, rather than just putting some special token into the URI. To me, that's maybe a detail. And I also find I guess I find it a little bit weird that the device is capable enough to provide its SBOM, yet the MUD file is elsewhere. Maybe that's a ocean to boil, but
if that's not so, the use case for when the SBOM lives elsewhere is when the device is not capable, right? The only thing the device is going to do is output a MUD URL, and that's it, right? Because that's a pretty simple thing. In that case, right, you could imagine a situation where the device has maybe a proprietary interface on it only, maybe a call home interface on it only, right? But no HTTP server, no CoAP server, no Apache, no nothing, right? And so you need a way to get the SBOM, even though the device doesn't have an interface, and so you go to the cloud in that instance.
Okay.
Fair enough.
Michael, he dropped out of the audio queue, so perhaps you've addressed his concern. Jeff is now in the queue, however. Jeff, you have the floor.
Hey, this is
Hi, Jeff.
Haas. Hey, so my comments are mostly on the SBOM contents. Comment one is I think that you probably will eventually, when they head down the road of providing some more structured content for the components that are part of the bill of materials. You gave the good example of like OpenSSL being able to have some way to enumerate that this component's in the system, and if you happen to know this is vulnerable, it's a thing for you to look for. So that's a useful thing number one. Last comment is that you're giving the ability to retrieve stuff through URI, and one of the things I think you probably want to have in here is the document that's retrieved from that URI probably should have some level of checksum embedded in the SBOM record to say, this is what I've actually expect to get from that URI. That will, I think, force a versioning conversation. And it means that if you do things like, I'm retrieving this bill of materials for this version of the software, I'm expecting that I have some level of integrity over what the contents are.
I would love some help on that. And so if you're interested, please feel free to contribute on that front. One of the things we have to just make sure we're managing is the multiple different formats and what should be internalized and what is externalized, but I would love to help. I mean, we're really early days on this. There's no, I don't have right answers there.
Understood. It's outside my area, but I'll see what I can do.
Okay, so.
And go ahead, Elliot.
Nope. That's it for me. So for the moment, I have one last
Warren,
question.
No, Warren Kumari, you have the floor.
So Warren Kumari for the record. Apologies if this was covered. I was juggling plates. For many things, I'm okay handing somebody a software bill of materials if it's somebody I already have a relationship with, right? If I know what they're going to do with the information, etc. If I'm just selling you a light bulb, I might not be quite as comfortable sharing the fact that it's using the following 17 libraries. Mm-hmm. How do you address, or do you just figure people should just share stuff because it's good practice?
I got a couple answers for you there, Warren, and thank you for your question. It's a good one. The first question is, nobody's forcing anybody to produce these SBOMs. At least I'm not. Well, I'll take it back. I'm not forcing anybody to produce these things, nor will the IETF. It might be the North American grid might force those people to produce something, or the FDA might force the medical manufacturers to produce something, but I won't. Second is to reiterate. I think you might have missed this earlier, or I might have said it poorly, which is probably more likely. That the information can be authorized, right? So one of the things you might do is you might point the person to the cloud. The cloud might then say, I need you to have log in order to get credentials. You might have to agree to certain terms. Or you might just say, I'm not giving them out, or call me if you really need it. So these are sort of the options. The goal here, Warren, is for me and for the IETF, I think, to not impose policy in this regard, but to allow flexibility for those sorts of policies. Does that answer your question?
I think Warren's still in the...
Yes, kind of. Although if you create a standard, they will come. If you make the standard, it's very easy for a regulator to say, this exists, therefore you must use it and publish it. Michael had mentioned that, it is specifically the light bulbs who should be publishing this. And while I personally agree, the light bulb manufacturers might not. Don't get me wrong, I like this idea, I support this idea. It's just there is some, attractive nuisance potential. If it exists, regulators will come along and demand it, etc.
We can't stop regulators from doing stupid things, that's for sure. Well, people tend to get, it's like trying to stop a bus that's out of control sometimes. You don't want to stand in front of it. But at the same time, right, what we can do, Warren, is perhaps state clearly that our view is that these might not be, we don't take a position on whether these are useful for everybody, right? And we could say stuff like that. I don't know how effective that would be, but or we could go further, Warren, and take the exact opposite approach and say, actually, we think these are really cool and you should do them. But I think before we say that, we have to answer the other question, which is, how do you know if something is really vulnerable? Lest all of our phones start ringing off the hook, we stop going to IETF, so we start working for customer support.
There's been a few discussions on this in the chat. Doug Montgomery started, maybe the SBOM should always just point to a manifest that we define, including the checksum. Michael said, Warren, it's precisely that light bulb people want to know the SBOM for. Jeff Haas said, agreed, Doug. What I'm mostly arguing is the manifest needs a bit of structure for audit and enumeration, and the SBOM record needs the ability to identify a specific version of the manifest. Doug agrees. I was thinking the SBOM manifest could provide a level of indirection for all the possible encoding formats. And Warren to Michael, yes, but the light bulb manufacturer might not want to share that. If the standard exists, people may be forced to publish using it. I personally think it is useful, but Michael, yep, some regulators might insist that it's not really our problem. And Doug, larger user communities are already requiring these. I don't think the existence of an interoperable signaling message will change that. And Michael, to Doug, the SBOM is signed. So it sounds like To the last bullet point, there is some interest. I'll forego the hum for saving us 35 seconds, and we'll take this to the list. But I think there's both interest and some things to be discussed and worked out to push this work forward.
Okay. Thank you very much for the time, Joe. I appreciate it.
Sure.
And
thank you, Elliot.
everyone for your comments.
Moving right along, I think, Bo, you're the next speaker for a Yang model for network and VPN service performance monitoring. So, and you're already there. So take it away.
Okay. Can you hear me?
We can.
Yes.
Okay. Hello, everyone. I'm here to talk about the Yang model for network and VPN service performance monitoring. Next, please. This draft was initially discussed in BAS working group since it defines VPN service performance monitoring. But during discussion, it was said that there was concern that this work may not belong to the scope of BAS working group. So we proposed the draft in OPS working group in this meeting. And this VPN performance monitoring is try to fill the gap for the VPN service monitoring for the layer 3 VPN, and also we are also taking account of layer 2 VPN also for the service delivery automation delivery. So we try to use this model to send the notification to the to client layer about how the VPN service being status. And so, and here's the assumption of this draft. This draft doesn't try to introduce some new metrics for network performing or monitoring. And this is just for using reuse existing metering protocols and just try to expose this from a network level and also the service level. So next, please. This figure is try to give a more clear view about why this which place this modeling is fitting to. Currently, layer 3 NM and also layer 3 NM work has been working on in the progress in this working group, and they are doing for the configuration, the service configuration. But this model is at the same level and trying to collect the different performance monitoring status at the service level. In that way, the client can have the more clear view about what the service about, like what kind of layer 3 VPN routes has been active used, or other like what kind of this service status has been going on, like whether the loss, jitter, bandwidth, the usage will be look like. So next, please. And this is a example that we are trying to give a clear view of what this model can be work for. Like from the service level, there are two sides, side A and side B. And the network level and service level, they will more have more interest in the what's going on between C1 to C2. They doesn't care too much about the underlay performance. So in our draft, we are trying to hide the like per link performance and also like per tunnel performance being like aggregate all those metrics together and just expose the C to C, C1 to C2 metric to the client layer. So next, please. And another part of this model is try to show what's VPN service topology and underlay topologies relationships. Like in the picture, there are two VPN. One is hub and spoke. The other is a point-to-point. And they will have some relationship to the underlay topology. And then in this modeling, there will have the relationships from the performance monitoring level, that what's the relationship with the underlay topology and VPN service topology. Like what the site will be located in node 1, node 2, node 5, and then there could be abstracted link between those nodes, and what that will be, the performance metric will be. Next, please. And here's the approach we think the VPN service performing can augment to the current basic network topology model. We just augment the per node. They will see whether this node is for the specific site, and how many routes for this network. Like if this network is implemented with an VPN technology, then what's this network will support how many routes. And then at the level of the abstract link, what will the tunnel type, we use the link type to show what could be the P2P tunnel could be used for this abstract link. And then on the P associated with the C link, there will be show the bandwidth usage and other performance metric would be. Next, please. Then we also give the example whether this model can be used for wire YAM push, like the device, the management system could push the data to the client layer of this model, and also the client layer can use on-demand retrieval by some RPC to polling this monitoring model. So next, please. So currently, this model just import VPN common module to reuse VPN common definition or the grouping. And we also use service type, role, VPN topology, defining VPN common YAM. But we also define that there could be role for different node, like some maybe the P role, or some maybe the P role or ASBR role, but currently doesn't defining VPN common YAM. So we are thinking whether this also can be included in VPN common YAM. And we also think this draft is in a good as a good basis for the working group adoption. So we are thinking whether the working group think this is a quite useful draft to fill in the gap that the current VPN service model management. That's all. Thank you. Any comments?
Sorry, I have to get my mic working. Any comments, as Bo asked? I had maybe a question, Oscar, if you're still around in particular. I saw you mentioned this draft on your slides. Bo, you're asking for adoption. I independently haven't seen that much conversation. I may have missed it on the list concerning this. So I'm curious as to how much. I mean, we can do a hum, but how much support, how much iteration has gone on respective to the other, at least the adopted work in the L2 and L3 NM modules. I'm trying to understand. Clearly, there's some integration there. There's some there is some thought of interoperability, but I'm just curious what the thinking of that group has been on this module. Okay. Okay. Well,
Chin, are you going to say something?
Yeah, this is Huawei. Actually, we also have a young model framework. Actually, we identify these missing pieces. So that's why we bring this worker, to try to fill this gap. So we actually have some discussion with L3 NM design team about this, and we think it's better, to actually to move forward for this worker. So, so Oscar or Mohammed, do you have anything to add here?
Rob is in queue. Rob, you have the floor.
Apologies, I had to step out for a couple of minutes. I missed the very end of that presentation and any questions you asked. But one question I have is, I think, Bo, you mentioned this had been presented in BESS before. I was just wondering how much discussion had happened in BESS, or how much maturity is this draft? Is it still relatively fresh, or had it been in BESS for a while?
Yeah, to answer Robert's question, actually, this draft has been around in BESS for a while. Actually, we actually present this draft. Actually, got a lot of interest, but talk with the BESS chair offline. They think it seems for this work not in the scope of BESS. So they actually they put in this draft in a covered option queue, but they are hesitant to adopt this. So we in last IETF meeting, we last IETF interim meeting, we also present this work in BESS, and BESS chair also have some concerns. So we raised some discussion to address some concern from the chair to clarify, for example, whether it defines some new metric. Actually, we actually get this resolved and with this new version update, and we also check routing area director about this, but we didn't get feedback. And so we think actually, based on indication from the BESS chair, we think they think maybe this work not in the scope of the BESS. So that's why we bring this worker to OPSAWG area. Yeah.
Okay, I mean, that sounds interesting to me. I'd be interested to see if it gets some reviews here and comments on this draft.
Okay.
Sorry, I was jotting some notes. I agree with Rob, hence my question. I would like to see more conversation on list about this and how it fits within some of the other L3, L2, NM work before we start a call for adoption on this. But thank you very much, Bo.
And I also have one more question.
Oh, sorry.
Is this related to the L3 and L2 NM, or it's related to the SM, the service model, or the network model?
Chin?
Can
Oh,
to answer your question, actually, Bo actually maybe get muted, and actually this is a generic performance management model, so it can be applied both L3 VPN and L2 VPN, and that's the goal for this job. Yeah.
So I mean, this is a complement to the network model or the service model.
Yeah, yes, this job that focuses on, for L2 NM and L3 NM actually focus on top-down service delivery. For this performance management model, actually, focus on, is kind of top-down, is bottom-up performance monitoring, so that you can create the closed loop, build a fully automated system. Yeah, it's complementary. Yeah.
So my understanding it's a complement to the network models, right now in this work group. Okay, that's all.
Yeah.
okay. Moving right along, we've got Dan Lee. Let's get you queued up. Okay, Dan, you have the floor. And if you're talking, make sure you click the send audio, the little mic play button.
Yeah, can you hear me?
Yes, now we can.
Okay, good afternoon, everyone. I'm Dan Lee from Tsinghua University. Next, I will present our newly submitted draft about the source address validation, the problem of existing solutions. This is a collaboration work of Tsinghua University, Huawei Company, and H3C Company. Next, please. We know that source address spoofing is very
Dan, if you're still talking, you just suddenly cut out, at least for me. Oh, you fell out of the mic queue. And looks like you may have fallen out of everything. I don't see him listed anymore. Is there anyone else who can jump in on this draft? Hopefully he'll rejoin. Oh. Rob mentioned there's an icon lower right, circular arrows to reconnect the audio stream. But I don't think he's in the participant list anymore. Ah, he's back.
Oh.
Okay, Dan, you once again have the floor up, and he's once again up. There he is. You're back, Dan.
For the network problem here, yeah. So okay, I'll just continue. So a source address validation or SIF is important to prevent the source address spoofing in the internet. Next, please. Existing safe solutions can be roughly categorized into two types. That is host level safe and network level safe. For host level safe, SAVI is the most representative solution. But its problem is that it requires all the access networks to deploy simultaneously. If there are some access networks not deployed in SAVI, then there may still be source address spoofing in the core networks. For network level safe, it can be divided into ingress ACL and URPF solutions. The problem of ingress ACL solution is that it requires many configurations to update if there is a routing change or prefix change. And for URPF, It includes strict ERPF, loose ERPF, feasible path ERPF, or FP ERPF, and a recent proposed enhanced feasible path ERPF or EFP ERPF. In what follows, I will describe that existing ERPF solutions cannot cover all the scenarios in practical network. Next, please. First, let's look at strict ERPF. It takes the source address as a destination address to look up the FIB. And if the outgoing interface of the FIB matches the incoming interface of the packet, then parse it. Let's use this figure as an example. Router 1 advertises its prefix P1 and P2 to router 2, and router 2 further advertises to router 3, while router 1 only advertises its prefix P2 directly to router 3. In this case, if router 1 sends a valid flow, here we use flow 2 to represent it. It's okay if it sends this flow to router 2 and router 2 further forwards to router 3, then router 3 will just incorrectly delete this flow and interface 1. Next, please. For loose ERPF, it also takes the source address as a destination address to look up the FIB. And if the address exists in the FIB, then pass it. We just use this same example. If router 1 sends a flow with a forged source address, which is source address P3 in this case, if it is sent to router 2 and router 2 further sends to router 3, this flow actually will be incorrectly accepted and the interface 1 of router 3. Next, please. For FP ERPF, it takes the source address as a destination address to look up the RIB instead of the FIB. We know that compared with FIB, RIB has more routing information. So in this same example, if router 1 just sends a flow 3 with a source address P1, with a source address P1, actually this flow will be incorrectly deleted and interface 2 of router 3 because router 3 learns the prefix of P1 from router 2, not from router 1. Next, please. Next. Okay. Actually, to overcome the problem of FP ERPF, EFP ERPF is recently proposed. There are two algorithms in EFP ERPF, algorithm A and algorithm B. Both of them are designed for inter-AS keys. In algorithm A, AS will set all the prefixes received for another AS on each customer interface that received an update. Let's take this figure as an example. AS1 advertises its prefix P1 to AS2, advertises its prefix P2 to S3, and advertises its prefix P3 to S5.
It seems we lost Dan
And you
again.
fell out of the audio again. Yep, and you're back, Dan.
Again.
Sorry. So in this example, if we run algorithm A, S4 will just combine all the prefixes it learns for S1, that is P1, P2, and P3, and it will include this set in the RPF list on each of its customer interfaces that it receives an update, that is interface 1 and interface 2 in this case. So when S1 sends flows with a P1, P2, and P3 as the source address, these flows will be correctly accepted and interface 1 of AS4. Next. However, if we just slightly change the setting, if we assume that S1 only advertises the prefix P1 and P2 to S3 and does not advertise any prefix to S2, in this case, if again S1 sends 3 flows with P1, P2, and P3 as a source address, sends the flows to S2, and S2 further forwards to S4. In this case, these 3 flows will be incorrectly delayed in the interface 1 of S4 because S4 does not receive any update from interface 1, so it will not put these prefixes into its RPF list. Next. So to overcome this problem, in the EFP ERPF proposal, there is another algorithm as algorithm B. Algorithm B runs like this. Each AS will put a set Z on all of the customer interfaces. Z is composed of 2 parts. One part is all the prefixes learned from its customer interfaces. In this case, that is P1 and P2 of S1. And the second part is the prefixes learned from its peer or provider interfaces. In this case, it is P3. So Z actually is just the union of these 2 parts, that is P1, P2, P3, and S4 will put this set on all of its customer interfaces, no matter whether it receives an update from that interface. So in this case, S2 will put the RPF list of P1, P2, P3 to both interface 1 and interface 2, although it does not receive an update from interface 1. And again, if S1 sends 3 flows with P1, P2, P3 as a source address, all of them will be correctly accepted at the interface 1. Next. However, next we will just show some cases to demonstrate that existing ERPF solutions cannot cover all the scenarios. Next. We have 2 cases. The first case is about the inter-S scenario. In this case, there are 3 administrative domains, or ADs. We have AD1, AD2, and AD3. AD1, there are 2 ASs, S1 and S2. AD2 has 1 AS, that is S3, and AD3 has 1 S, that is S4. So S3 advertises its prefix P1 and P2 to S1, and it does not advertise any prefix to S2, while S4 advertises its prefix P3 to S2. Now, if S3 sends 2 packets, one valid packet with P1 as the source address, and an invalid packet with P3 as the source address. So the strict ERPF, loose ERPF, and FP ERPF will have some problems to either to drop the legitimate packet or to accept the forged packet. For EFP ERPF, if we run algorithm A, it will drop the legitimate packet, and if we run EFP algorithm B, it will accept the forged packet. Next. So the second case is for intra-AS scenario. In this case, there are 3 administrative domains in a single AS as AD1, AD2, and AD3. The routing between AD1 and AD2 are learned from static routing instead of BGP advertisement. So again, if AD1 sends 2 packets, that is with a valid packet with P1 as source address and an invalid packet with P3 as the source address, if we run strict ERPF or loose ERPF or FP ERPF, it will again either drop the legitimate packet or accept the forged packet. And the EFP ERPF is designed for intra-AS case, so does not apply in this scenario. Next. Okay, that's all of my presentation. So we find that the existing ERPF technologies cannot cover all the network scenarios. So more advanced technologies are required to just to get a more accurate safe in network level. So your comments are appreciated. Thank you.
Comments from the audience?
Yes, comments from the from the text. And also, Eric.
Yeah, simply nice explanation, Eric Green from Cisco. Nice explanation about what's happening in multiple servicing. I just suggest that you present this draft into the OPSEC working group, where all this scheme has been defined. Just a comment, not a question.
Thank you. Thank you very much.
Yunan Gu?
Yuna, are you going to talk about something?
Hey, I just a quick reply to Eric's comment. Yes, in fact, this work we intend to put it to the OPSEC working group, but you know, there's no session this time, so yeah, we would like to talk this at the OPSAWG this time and see. I mean, we mainly want to get some feedback from the working group. So yeah.
Thank you.
And Warren's question was answered. Any other comments on this work? Well, thank you, Dan. With that, that concludes the Ops AWG portion, and it looks like Rob, we owe you a thanks for stepping in and taking some good notes there I've seen. So appreciate that, and I will hand it over. I think Warren's coming in. Warren, I was going to hand it over to you and Rob for the ops area, unless there's some ops AWG comment you'd like to make.
Yes, kind of, sort of. It seems that you all are the chairs, so if you wouldn't mind, you know, continuing to drive the slides and meeting part, sure, that would be great.
I figured I would, so I preloaded them for
you. So, hi everyone. Welcome to the Ops Area part of the combined Ops Area and Ops AWG meeting. The chairs have kindly agreed to carry on running the session and dealing with slides and things like that. And hopefully they will be willing to also help with minutes, or can somebody else do that? Chairs, are you okay with helping with minutes?
To help with minutes here. I've got the CodeMD open on my iPad, so happy to help.
Thank you very much. And as just a very quick update, we've been discussing the possibility of having something like an IoT. Oh, yeah, I guess I should turn on my camera as well. Would probably be politer. There we go. Hey. So yeah, it's a very quick update. We've been discussing the idea of having an IoT operations and onboarding working group. This is still very much an early discussion, and you know, there isn't really a charter yet or anything like that. I just want to give people a note on that. But I think it's more important that we have some time for Benoit's SANE service assurance presentation. I know that I had read the drafts a couple of times and it didn't really click with me until I saw one of his presentations on this. So I will hand it over to Benoit, and if we have any time at the end, we can do a quick update on our ideas behind a Ops IoT operations working group, which, as I say again, is very much still an early discussion phase. So Benoit, take it away.
All right, very good. Can you hear me?
Can indeed.
Okay, very good. So time check, how much time do we have?
Looks like we have 26 minutes, 16 minutes left plus 5, so 21 minutes.
All right, so, okay. Let me start. So I'm Benoit, I'm with Cisco, and I want to present those two drafts. Those drafts have been updated yesterday because we received some feedback from the hackathon last week. And next to those two drafts, we have one presentation where Corian will be presenting the results of the hackathon and how he implemented SANE architecture in open source. So we thought it was interesting to cover that as well. So maybe we want to keep all the questions for the end to be respectful of the time. Okay, so next, please. The issue in the proposal, well, I've been presenting a few times already, and last time I think it was Joe. Thank you for that. So we know that whenever a service is configured, it does not imply that the service runs correctly. So if we could solve the issue to understand that whenever a service degrades, we could understand where is the fault, what are the symptoms or the root cause if we could deduce it, but also the reverse. Whenever we know that the network component or a specific feature degrades or fails, what are the services that are impacted? And this is what we did. We just decompose a service into smaller components, into what we call subservices. And then we created an assurance graph. And we want to assure every single component independently and infer a health score for a service. Now, this architecture should be complemented by end-to-end probing, typically OWASP or TWASP, which is threshold based on delay, packet loss, and jitter. Okay, next slide, please. And I'll be quick with the slides because I want to show you one screenshot, which is a proof of concept we did. So actually, we can go to the next one and the next one. So we have at the top an orchestrator. An orchestrator configure services. We discussed today about L2VPN, L3VPN. And what we do out of that is that we extract the service type and service instances into what we call a SANE orchestrator, and we deduce the intent being basically the services. And what we do is that we're going to compute the assurance graph and assure every single subservices independently with the SANE agent. And the SANE agent will go and monitor the specific metrics which are required for the assurance. And what we do is that we're going to stream the result of the assurance graph, being the health score and the symptoms. So if you go to the next, okay, and also the Yang. So the Yang models there, basically, as we know that the Yang generates APIs, we are solidizing the Yang models, which are the interfaces between the SANE orchestrator and the SANE agent, but also what is streamed. And if you go to the next slide, what we don't plan to solidize because it's too difficult, we're not going to solidize an orchestrator. There is plenty of code which is basically which makes it impossible to solidize. And we're not going to solidize a SANE agent. However, solidizing the APIs means that this graph would become distributed. I'll come back to that point. Okay, and slide 8, please, because I made a mistake in the order. So this is basically a proof concept that we created, and this is maybe what will make you understand what we're doing. We've got at the top a service. It's, let's say, a tunnel in this case, a tunnel for Coca-Cola. And all the concepts I explained in the draft here, I'm going to go and explain them here. So this service to work, it depends on the left-hand side on the health of the tunnel interface. And then that interface depends on the health of the loopback interface. That depends on the health of the device. That depends on the health of the data plane and telemetry. But also in the middle, that service depends on the health of the connectivity between source and endpoint. So this is what we mean here. So what we do here is, as I mentioned, we're doing the assurance of every single blocks in there. And we infer, this is important, we infer the health score of the top service here. We've got a couple of boxes that are orange. So we see on the right-hand side that the value of the service is 0.5. So, okay, it's not 1, it's 0.5. We believe there is something wrong. The value here is that we show where problem is not, but also where it could be. And for example, the tunnel on the left-hand side, tunnel interface, I've not displayed the symptoms, but there is no traffic. Clearly, there is something wrong. I clicked for that one on the ECMP fair load, and we see a symptoms telling, okay, it's not fairly balanced, which means that we're doing baselining. So what does it imply? We're not trying to go after the assurance where interface is down. This is just too easy as an example. We just do closed loop automation, we enable it, okay, big deal. We're after the things where we're able to tell the symptoms on specific components. And you see also dotted lines and full lines. We've got the notion determinant draft, which is about informational dependencies and impacting dependencies. If I've got a dependency on ECMP, is my service affected? Well, it depends. However, it's already a good symptoms to have. And I see a message from Reshad telling that it's difficult to see the drawings there. I put like a high quality in there, but and I'm not sure what happened. I'm not sure if it's clearer if the slide turns. I haven't done anything. Okay, so if you look on the right-hand side, oh, thank you, that is way clearer. If you look on the right-hand side as well, if you click on the fair load, you see the list of impacted services, which is key. Whenever you do troubleshooting of a network, you have to understand, okay, there is one issue with that component, and I know it impacts many services. So this is what we've been doing with the Yang modules, with the POC. And okay, if you go back to slide 7 now, please. I hope I explained all the concepts right. And what has changed since last time? Well, we stress that we have an open architecture, a flexible architecture that allows to have distributed graphs. Some of those graphs could be in a router. Some could be, coming from an orchestrator with a tunnel, L2 VPN, L3 VPN, but also for wireless, also for 5G or a VIM. And this is one of the difficulties we see with operators, is that we've got different groups in charge of different aspects of the network. Because you've got Yang models for all these, for this graph, we could easily add dependencies. Second change, we clarify that we need to have NTP all over the place, and we introduced the symptoms history start, the time and date at which the symptom history start for a subservice instance, either because you're just starting or because there is garbage collection. But whenever you start collecting all the symptoms, it's important to know. Next slide, please. And again, okay. And the lesson learned from the hackathon, and then Corian will be covering what he did as well, is that we changed the assurance graph version and last change, if you know about the Yang model. So the ability to keep a history of the assurance graph for post-mortem. Let's assume that the operator has got an issue, had an issue yesterday at 3 p.m. You could go back and see exactly what happened. We also describe better what a change means, and we clarify a couple of things in a draft. For example, we had 2 notion of labels. So, okay, maybe it was quick, but first of all, I presented already, and second of all, I want to make sure we've got time for Corian to present. I believe this is my last slide, and we'll have a Q&A in the end. Thank you.
Can you hear me?
Yes.
Okay. So hello everyone. My name is Corian Edelin. I am a postdoc at University of Liège since 5 months, and I'm working on service assurance for intent-based networking. Slide, please. So I am writing an open source SANE agent alongside two visualization tools. So the agent can be described in 3 steps: the inputs, the metrics, and the rules. So first, the inputs works by discovering data sources and then gathering data. So what I mean by discovering data sources is, for instance, you will enumerate all the API for all hypervisors and find out which one is running on the node that you run the DX agent on, and then pull data from the virtual machine. So this is the same logic that you apply to various data sources, such as the /proc, netlink sockets, and others APIs. Basically, a lot of APIs. So these data that you gather here, they are all vendor dependent. So the next step, the metrics steps, is a translation layer or a normalization layer to make them independent from their source. So we translate them in terms of name, in terms of units, and in terms of type sometimes as well. And in this step, we also discover subservices alongside their dependencies. So let's say you run a few interfaces on the device that you run your DX agent on. Well, you want to discover if they run a DNS subservice, if they run a DHCP subservice, or if they are running any ECMP, and so on and so forth. And the final step is the rule step, which aims at applying rules on those normalized data in order to derive symptoms, which are then used to compute a health score per subservice. And finally, the health maluses are transmitted alongside the subservice dependencies. So you can access to this data via shared memory by using the DXTop app, which is a basic ncurses app. Or you can export those data via GNMI using the IETF service assuring young model into a more visual JavaScript-based web app. Slide, please. So this is what it looks like, but it is very small. So on the DXTop side, you see that it has multiple screens. This screen is actually the metrics. So you can see all the vendor independent value. At the top, you see the red lines. There are positive symptoms. And just after, you can see the full identification of the node that triggered it. And on the other side, you see the tree. So each node represents a subservice and each edge represents a dependency. So you can see how the health score propagates. You can play with it because it's in JavaScript. And you can also dig up for root causes of health deterioration using this tool. Next, please. So yeah, you can zoom out, please. So the critical part of this tool is the rule engine, because this is what is used to highlight the symptoms, which are later used to derive health scores. So the idea is to leverage subservice expertise to highlight anomalies using rules. So rules are basically expression based on variables, which are the metrics, the vendor independent data, which are at your disposal alongside basic operators and a little bit more complex operators. So at the bottom, you see examples of rules. So you have a name to define it, a node to which it should be attached and checked, a severity factor, and on the right side, the expression of the rule. So for instance, the first one checks if the interface has changed state up to down, down to up 6 or more times on the last minute. And if it did, the symptom is triggered. But you can also check buffer occupancy ratios, check for any increment of a given error counter, do some thresholding, combine rules together. So the last rule, for instance, is checks consistency between MTU and interface type. Slide, please. So in my opinion, this is a very promising approach because it has a lot of use cases. You might want, for instance, let's say you have this company which owns a lot of devices on which you are running a same agent, so the DX agent, for instance, and you have the company as a client that uses a subset of those devices. So what you can do to assure your client service is pull the assurance tree of the subset of network devices and concatenate them together to build your client service assurance graph. And you can then monitor the health score of the root node, which would represent your client service health. But there are also other interesting usage of this. For instance, you can find the consequences of a component failure by using the dependency. So you can find what are going to be the consequence of this and what are going to be the impacted clients, for instance. And of course, you can still use it to monitor multiple unrelated subservice health. Slide, please. So we participated in the hackathon with the aim of adding a little bit more interoperability between open source tools in the same architecture. Slide, please. So this is what we aimed at doing. So we wanted to monitor a VPP instance running in a virtual machine. So VPP is a kernel bypass framework, basically forwards packet very fast.
And just a very quick note, we are running really low on time. So if you can.
Okay. So we interface it with the Excel agent and then collect it in Telegraph PMSCCT and to a visualization tool. Slide, please. So this is what happens when the health is at 100%. Slide, please. So this is chronograph. So then we see a health score that decreases. Slide, please. And you can use the tools to dig up for the root causes. So for instance, use DXWeb with your node GNMI target as argument. And here, if you zoom very close, you can see that the red path basically at the bottom leads you to DPDK buffer allocation error and to a lack of huge pages. So this problem can be fixed straightforwardly by allocating more huge pages. Or you could have also used the DXTop interface. Slide, please. We did also more interoperability work with Alexandre Leonardi adding support for the Excel export to the Cisco SAIN collector. Slide, please. So finally, the immediate next steps, at least for me, are working on a more complex rule engine to allow for more versatility in the rule expressions. Possibly to investigate the addition of an end-to-end probing tool as input source to have some kind of empirical view of what is going on. Then the next big step is this multi-node graph concatenating step, which I believe is very interesting. There is also some ongoing work by Canon to add GNMI support to PMSCCT, which would allow the Excel agent to work with it. And at one point, I will work on a paper on a specific use case of this software. And finally, the value of this tool relies on the amount of input and on the amounts and the quality of rules. So for that reason, any contributions are warmly welcomed. Slide, please. And back to Benoit.
Okay, so I know that we are running out of time. So basically provide feedback and consider a couple options at point in time.
We have about a minute and a half left, so we can play question lottery. And somebody's going to get cut off midway through their question or answer if they like. If anyone has a question?
Yeah, I commented in the message box, and I think there are many intent-related work in an MRG. Should this be in an MRG? Or did you present it?
So we're presenting in both NMRG and OPSAWG. Since we plan on standardizing interfaces with Yang model, and since it's a new architecture, I believe it fits OPSAWG/Ops area. NMRG is more a research aspect, and by the way, we've been developing this project for 2 years now, so I believe we did our research part already. Hence the proof of concept and the Yang module API and the hackathon for interop.
And I suspect we actually run out of time, but I don't think we managed to get another question in. So thank you very much, Benoit. and everybody else for showing up for the session. Let's carry on the discussion on the mailing list. I personally think that it's interesting to discuss it in NMRG, but I think the actual work part of it is likely to happen somewhere in this thing, but still interesting to discuss there for more feedback. But I personally would be supportive of this work happening here in OPSAWG or related. But that's my personal view only. And with that,
thanks, Rowan.
I suspect we're about to get cut off. So thank you very much. And also thank you to the chairs for being willing to help run the slides, etc. And let's call this the end. And apparently I cannot end the room, only the chairs can do that.